Final Project by Nick Lee. The parts of an earthquake. The epicenter of an earthquake is the area on the Earth's surface just above the focus, which is the central point of energy release of an earthquake, which can be anywhere from the surface to 700 kilometers deep. Faults. In a normal fault, the hanging wall, positioned over the fault, moves down relative to the fault wall, positioned under the fault. In a reverse fault, it's reversed. The hanging wall moves up relative to the fault wall. In a strike slip fault, the two walls move past each other in a parallel fashion. P waves and S waves. P or primary waves are faster waves parallel to the wave motion and can travel through solids and fluids. S or secondary waves and only travel perpendicularly to the wave motion through solids. The fact that S waves cannot travel through the core of the Earth is one way we know that it is a fluid. A seismometer is a machine that measures seismographs, which show information about an earthquake. The markings on the seismograph show the amplitude of the P waves and the S waves. You can use a lithograph to measure the amplitude of the S waves and the distance from the epicenter to calculate the magnitude of the earthquake. The magnitude of the earthquake is used on two scales. The Richter scale is a scale used to determine magnitudes of earthquakes by base 10. Each increase in magnitude on the Richter scale by 1 is a strength increase of 10. An increase in magnitude by 2 is an increase in strength of 100. An increase in magnitude by 3 is an increase in strength of 1,000, and so on. However, this scale only goes up to magnitude 8, or about 10 to the 8th in strength. Above this magnitude, we must use a different scale called the moment magnitude scale, which measures the magnitude of the earthquake relative to its rupture size. You can also calculate the distance an earthquake is from the epicenter using the formula D equals Vt, where D is distance, V is velocity, and T is time. To do this, simply set the P wave equation D equals Vt equal to the S wave equation D equals V times quantity T plus X, where X is the additional time the S wave takes to arrive, then solve for T and plug that into the P wave equation D equals Vt to find D. An example. You feel S waves traveling at 6 kilometers per second arrive 5 seconds after the P waves traveling at 9 kilometers a second. How far away is the epicenter in kilometers? Here are the steps. First, set up the equations. P wave, D equals 9t. S wave, D equals 6 times quantity T plus 5, since the S wave takes 5 additional seconds to arrive. Next, set these two equations equal. 9t equals 6 times quantity T plus 5, or 9t equals 6t plus 30. Now solve for t. Subtract 6t from both sides to get 3t equals 30, and thus t equals 10 seconds. Then plug this value of 10 seconds into the P wave equation to get D equals 9 kilometers a second times 10 seconds, or 90 kilometers. Tsunamis. A tsunami is a wave produced by an undersea fault. It starts out less than 1 meter in height, but traveling at 800 kilometers an hour, it can reach up to 30 meters high, causing massive destruction. Two of the most devastating tsunamis occurred in Thailand and Japan, which left Japan in ruin, featured by an earthquake.